Today we are going to discuss on part 9.2 string builder, mutability, method chaining and equals trap. So this is part of part 9 core Java API classes. Okay. So string versus string builder, the core difference, right? So string s is equal to say hello and s.concat world, right? So system out.println s, it will be hello only. Why? So we call concat on s and concat creates a brand new string hello world and returns it, but we did not capture that return value, so the new string is immediately discarded. S was never touched, so s is still hello. This is the immutability rule that we covered. Every string method returns a new object, the original, it never changes. Next line is string builder sb and equal to new string builder hello, right? So sb.append world and system.out.println sb. What does it print out? It prints out hello world. Now string builder we call append on sb, right? Append does not create a new object, it modifies sb directly in place. We do not need to capture any return value for the change to take effect. So this is the fundamental difference with string. String is immutable, every operation creates a new object, and string builder is mutable, operations change the same object. Okay. Capacity versus length is a trap, right? So string builder sb2 is equal to new string builder. Here capacity is 16 and length is 0. String builder sb3 new string builder 100. So capacity here is 100 and length is 0. And string builder sb4 new string builder high, so it will capacity is 18 and length is 2. Okay, the string builder has two separate concepts that the exam deliberately confuses: capacity and length. Capacity is the internal buffer size, how many characters the string builder can hold before it needs to resize itself internally. Length is the actual number of characters currently stored. That is the number you care about, right? So sb2 is created with no arguments, default capacity is 16, but no characters have been added, right? So length is 0. sb3 is created with 100, that is 100 is the initial capacity. It is the pre-allocation telling string builder to reserve space for 100 characters up front. No characters have been added, so length is still 0. So if we do system out.println sb2.length, we will find 0, and system.out.println sb3.length, there also will find 0. So both return 0. The number passed to the constructor is capacity, not content. So sb4 is created with string high. So now there are actual characters, length is 2. The capacity becomes 18, which is the length of high plus the default 16. Okay. So we come to key string builder methods, right? So let's trace through each method step by step on the same string builder object. So we have to remember that every one of these methods modifies string builder in place. Okay. So starting point is string builder sb is equal to new string builder hello. So sb holds hello 5 characters, indices 0 to 4. Okay. Then we have append sb.append world, right? So hello world. So appends world to the end, and sb now holds hello world 11 characters. And then we have why 11 characters? Because there is a space between hello and world, right? So when we did sb.attend world before w, there was a space. So now insert sb.insert 5 comma then within quotes comma, right? So hello comma space world, inserts a comma at index 5. So everything from index 5 onwards shifts one position to the right to make room. Before the insert, index 5 was the space before world. The comma slides in there. sb now holds hello comma world 12 characters. Okay, and then comes delete. So sb.delete 5 comma 6. So the deletes characters from index 5 up to but not including index 6. That is just the comma at index 5, right? One character removed. So it is hello world, comma is gone. And then we have replace sb.replace 6 comma 11 then java, right? Hello java. So replaces the characters from index 6 up to but not including index 11 with the string java. So index 6 to 10 is world 5 characters, java is 4 characters. So the length changes. So sb now holds hello java 10 characters. Reverse sb.reverse is the reverse of hello java, right? So it is avaj and then olleh, right? So reverses every character in the string builder. Hello java flipped character by character becomes avaj then olleh. So sb now holds avaj olleh, still 10 characters, right? And we have length, caret, and toString, right? So if we do system.out.println sb.length, so it will give us 10, and then string system.out.println sb.caret caret 0, it will give us a, and system.out.println sb2 string avs Now length returns the current character count, right? So that's 10, and caret returns the first character a, right? Because after reversing, avs starts with a, and toString converts the string builder content into a regular immutable string. So this is how you hand string builder content to methods that expect a string. Okay. Method chaining returns the same object. So what is method chaining? So here we have string builder sb is equal to new string builder, and then sb.append hello, append comma, then append world, then append exclamation sign, right? So system.out.println sb will print out hello comma world space world and then exclamation. So every string builder method that modifies content returns the same string builder object. It returns this. So when append finishes, it hands back sb itself. That means you can immediately call another method on the result, which is another call on the same sb, right? And again. So this is called method chaining. One line, 4 append calls. So all on the same object. The result is hello comma world built up in a single statement, clean and efficient. Okay. The shared reference trap is here you see string builder A is equal to new string builder this, string builder B is equal to a.append java. Now here is where people get caught, right? So what happens is that A is a string builder holding this. We call a.append java, append modifies in A in place, so A now holds this java. Then append returns this, right, which is A itself. So and we assign the return value to B. So B is now B is not a new string builder. B is not a copy. B is literally the same object as A. Both variables point to the exact same location in memory. So if we print system.out.println A, so this Java, system.out.println B, this Java, right, and system.out.println A equals B, it is true. Both print this Java because they are the same object. A equals B is also true because it's same reference, same memory address. Okay. So modifying through B changes A. If you do b.append exclamation, so and you do system.out.println A, you will find this Java exclamation. So we call append on B. So B and A are the same object. The exclamation mark is added to that one shared object. Okay. So when we print A, it shows this Java exclamation. The change made through B is immediately visible through A. Okay. So string builder equals does not compare content. Okay. So string equals content comparison. So if we have string s1 equal to hello and string s2 equal to hello, so we do system.out.println s1 dot equals s2. Is this true? So string overrides the equal methods from equal method from object. So it replaces the default behavior with a character by character content comparison. Okay. So s1 and s2 both hold hello, same 5 characters in the same order. So equals returns true. Whether they are the same object or different objects, it doesn't really matter. So content is all that counts. So this is what you expect and what you have been using all along with strings. Then we have string builder equals and reference comparison, right? So we have string builder sb1 equal to new string builder hello, and we have string builder sb2 is equal to new string builder hello. So and we do system out.println sb1 dot equals sb2, so it says it's false, and then system out.println sb1 equals sb2, it says false. So this is the trap. String builder does not override equals. Okay, so it inherits the default equals from object, which simply checks whether both variables point to the same object in memory. So this is identical behavior to the equals operator, right? So sb1 and sb2 are two separate objects created with two separate new calls. Same content but different objects at different memory addresses. So both equals and equals returns false. Okay. So if you come from a string background and instinctively calls equals to compare content, you will get the wrong answer with string builder every single time. We have to remember this very crucial concept. This one is. The correct way to compare StringBuilder content. So the correct way to compare StringBuilder content, systemout.println sb1 to sb1 dot toString, then dot equals sb2 to toString. Okay, so that will be true. So convert both string builders to strings first by using toString, then call equals on the resulting strings. Strings equals does not contain comparison correctly. This is the only reliable way to compare the content of two string builders. And same object both return true. If we do string builder sb3 is equal to sb1, then system.out.println sb1 equals sb3, it will be true. System.out.println sb1 equals sb3, it is true. So sb3 is assigned sb1 directly, no new, no append, just an assignment. Both variable point to the exact same object. Since string builders equals is a reference in comparison and sb1 and sb3 are the same reference, equals return true, and equals also returns true for the same reason. Both checks agree when it is literally the same object. Okay. The side-by-side comparison, the exam it loves is the string equals compare content. Two hello strings are true, right? But string builder equals compares reference. To hello sb is false. Okay, so we have to remember this. So that one line you have to remember is that string overrides equals to compare content. String builder does not. It uses objects equals which compares references. To compare string builder content, first you convert to string first with toString. Okay, so string versus string builder side by side summary. So the table that you are seeing there, this table brings everything together. Let's go through each row and make sure the reasoning is clear, not just the answer but why. Immutable string, yes, immutable, every operation returns a new object, the original is never touched. String builder, no, every operation modifies the same object in place, that is the entire reason it exists. Okay, and then equals, string overrides equals to compare content character by character. Two separate string objects with the same characters are equal, and string builder does not override equals. It inherits objects equals which compare references, memory addresses. Two separate string builders with identical content are not equal according to equals. So this is the most surprising now row in the table and the most tested on the exam. Thread safe. String is thread safe precisely because it is immutable. If an object can never change, multiple threads can read it simultaneously with zero risk, and nothing can go wrong when nothing can change, right? So string builder is not thread safe. So multiple threads modifying the same string builder at the same time can corrupt its content. If you need a thread safe mutable string, Java provides string buffer, which is essentially string builder with synchronization added. But string buffer is not on the OCA exam. And then we have method chaining. String methods return new string objects. You cannot chain them on the original. Each call produces something new. String builder methods return the same object, so you can chain append, insert, delete, reverse all in one statement. So each method picks up where the last one left off on the same object. Okay. In string pool, so string literals are automatically placed in the pool and shared. Two variables holding the same literals share one object. Okay, and string builder objects are never pooled. Every new string builder call creates a fresh object on the heap. There is no sharing, no reuse, no pool. Performance. If we are making many changes to text, appending in a loop, building up a message piece by piece string is very slow. Every change creates a new object and discards the old one. In a loop of 1000 iterations, you create 1000 string objects. You have to remember that. String builder is fast for this. One object modified in place, no garbage created. Okay. So if you are mostly reading and comparing fixed content, string is perfectly fine and simpler to work with. So use when. So string, fixed content, reading, comparing, passing around, the default choice for text that does not need to change. And string builder, building or assembling text dynamically, appending in loops, constructing messages from parts. Any situation where the content evolves through multiple steps. Okay. The bottom line is that string and string builder are not competing. They serve different purposes. String is the workhorse for stable text and string builder is the tool for construction. So know when to use each and know the differences the exam focuses on. Immutability, equals behavior, and the shared reference trap from method chaining. So we have come to the practice question. Let's trace this step by step. This question is testing two things simultaneously: the shared reference trap and the equals behavior of string builder. So line 1, we see string builder A is equal to new string builder OCA. A is created holding OCA one object in memory. A points to it. And line 2, string builder B equal to a.append Java. Dash Java. We call append on a.append. It modifies a in place, and a now holds OCA dash Java. Then append returns this, which is a itself. The return value is assigned to B. So B is not a new object. B is not a copy of A. B is the exact same object as A. So both variables now point to one single string builder in memory holding OCA dash Java. So b.append dash 17 we call append on B. Since B and A are the same object, this modifies that one shared object. So it now holds OCA dash Java dash 17. Both A and B sees this a change because both point to the same object. And then printing of A and B, right? So system out dot println A, it prints OCA dash Java dash 17 OCA, and then system out dot println B, OCA dash Java dash 17, right? Both print OCA dash Java dash 17, right? Same object, same content, same output. And A equals B, system out dot println A equals B, it will be true. Equals compares references, memory addresses. A and B point to the same object, same address, it's true. Then A equals B, right? System dot out dot println A equals B is true. String builder does not override equals, so it uses objects reference comparison. Since A and B are the same object, equals returns the true here also. Both checks agree because it is literally one object being compared to itself. Note that this doesn't mean string builder equals compares content. It returns true here only because A and B are the same reference. If they were two separate string builders with identical content, equals would return false. Okay, so complete output is B. Answer is B, OCA dash Java dash 17, OCA dash Java dash 17, then true and true. The lessons this question gives us is that B equal to a.append does not create a second string builder. It creates a second variable pointing at the first one. String builder equals returns true here, not because of content comparison, but because A and B are literally the same object. Okay, so if you want more, and we have 1624 questions like this with fully detailed explanation and timed exams, 29 full-length practice tests available at javalearn.clustermicro.com. You can register there, avail a 3-day free trial, and then can proceed from there. Okay. Thanks for your time.